download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about exothermic and endothermic reactions. Now, it is important to note that energy is moved around in chemical reactions and the overall amount of energy does not change. This is because energy is conserved in a reaction, which means the total amount of energy before the reaction is the same as the total energy after the reaction, and energy is only moved around. Okay, this means that the amount of energy in the universe will always stay the same. If the products of a reaction store more energy than the original reactants, then they must have taken in energy. But if they store less, then they would have given off that energy and transferred it to the surroundings. And that's where exothermic and endothermic reactions come in. So an exothermic reaction is a reaction which transfers energy to the surroundings. So an exothermic reaction is a reaction that transfers energy to the surroundings, usually by heating. And it's shown by a rise in temperature of the surroundings. So shown by a rise in temperature. Now, the best example for exothermic reactions are things like burning fuels. When you are burning fuels, you can physically feel the temperature coming off of the reaction, which is showing it transferring energy to the surroundings, and therefore it must be an exothermic reaction. So combustion is an example of an exothermic reaction. Neutralizations are also examples of exothermic reactions, as they transfer more energy into the surroundings than they take in. And many oxidation reactions are also exothermic. Okay, exothermic reactions have lots of useful examples and uses in everyday life. Hand warmers, for example, are exothermic reactions. Self-heating cans. These are all examples of exothermic reactions. So an exothermic reaction is one which transfers energy to the surroundings, and therefore there's a rise in temperature. So now what we're going to do is we're going to look at endothermic reactions. So an endothermic reaction, is a reaction which takes in energy from the surroundings. Okay, so an exothermic reaction transfers energy to the surroundings, whereas an endothermic reaction takes in energy from the surroundings, and therefore it can be seen by a fall in temperature of the surroundings. So a decrease in temperature shows an endothermic reaction has taken place. Examples of endothermic reactions are much rarer, but there of course is some. So the reaction between citric acid and sodium hydrogen carbonate is an example of an endothermic reaction, and also thermal decomposition is an example of an endothermic reaction. Okay, i.e. heating calcium carbonate causes it to decompose into calcium oxide and calcium dioxide, and this is an endothermic reaction. The uses of endothermic reactions are for sports injury packs. For example, the chemical reaction allows the pack to become instantly cooler without having to put it in a freezer. So it's very, very useful as a sports injury pack. Now, energy transfer can be measured, and you can measure the amount of energy released by a chemical reaction in a solution by taking the temperature of the reagent, mixing them, and then measuring the temperature afterwards. So for example, here we've got a polystyrene cup, and then we're going to have a solution, and we're going to place in a thermometer to take the temperature of that solution. Okay, we're then going to mix in what it is that we are reacting, and then take the temperature after. And that difference in temperature is going to show you whether it's an endothermic or an exothermic reaction. If the temperature has increased, it will be an exothermic reaction. where if the temperature has decreased, it will be an endothermic reaction. The biggest problem with energy measurements is the amount of energy that might be lost to the surroundings, and you can reduce this by putting the polystyrene cup into a beaker, like so, that contains cotton wool. So all this here around the polystyrene cup is cotton wool. This will give it more insulation. So this will give it more insulation. And putting a lid on the cup as well will stop any energy loss by evaporation. Okay, so the way we can make this a better experiment is by placing the polystyrene cup in a beaker of cotton wool and placing a lid to prevent and reduce evaporation. This method works for neutralization reactions or reactions between metals and acids or carbonates and acids. You can also use this method to investigate what effect different variables have on the amount of energy transferred. Okay, so you can really use this to measure the energy change. So the easiest way really is to take the temperature before, you mix the reactants, whatever it is you're trying to work out, if they're exothermic or endothermic, and then you take the temperature after. And as I said earlier, if the temperature went up, that tells you it is an exothermic reaction. And if the temperature went down, then it tells you it is an endothermic reaction. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. So reaction profiles are diagrams that show the relative energies of the reactants and the products. And below here I have drawn two different reaction profiles, and we need to be able to label them. So label each part and tell me which reaction profile represents exothermic and which represents endothermic. So I'm going to start off with this one here towards our left, and the bottom, the x-axis, represents the progress of the reaction, and along the Y it represents energy. Now this first line here for both of our reaction profiles represents the energy of the reactants. Okay, so the energy of the reactants. Now this is the amount of energy the reactants have before the reaction has taken place. Now if we draw a line, a dotted line from the energy of the reactants, this line up to here, up to the peak, so this line here represents something called the activation energy. Now activation energy is the minimum amount of energy the reactants need to collide with each other and to react. So really the minimum amount of energy needed for the reactants to actually react. That's what we mean by activation energy. And the second line on both of our diagrams represents the energy of our products. Okay, so that's how much energy our products have after the reaction has taken place. Okay, now you may realise, or you may have not realised, that in this first example here, the amount of energy of the products is less than the energy of the reactants, which means that energy must have been released into the surroundings, because no energy can be lost or gained. So if the energy has gone down, the energy must have been released into the surroundings. So this reaction profile here represents an exothermic reaction. Whereas in this example, the products have a higher amount of energy than the reactants, which means it must have taken in energy from the surroundings. And therefore this one represents an endothermic reaction. Okay, so we need to be able to identify the differences between exothermic and endothermic in terms of reaction profile. And you need to be able to look at a reaction profile and say which is exothermic and which is endothermic. In terms of exothermic, the amount of energy of the product is always going to be less than the amount of energy of the reactants. And in an endothermic, the amount of energy of the product is always going to be more than the energy of the reactants. Now the final bit we need to be able to label is this from the reactants, the energy of our reactants line, down to our energy of the products line. This amount here, this represents the amount of energy that must have been released into the atmosphere. So this line here represents the amount of energy that must have been released. Whereas if we go from here, this is the amount of energy the reactants have, up to the amount of energy the products have. This line here now represents the energy, or the amount of energy that must have been absorbed by the product. Okay, so here we have two different reaction profiles, one for exothermic and one for endothermic. You have to remember that in an exothermic reaction, the products have less energy than the reactants, so it looks like this. And in an endothermic reaction, the products have more energy than the reactants, so our reaction profile looks like this. So now what I'd like you to do is have a go at answering these questions here, and then we'll go through the answers together. So pause the video now. Okay, so let's run through the answers then. So really we just have to draw a rough sketch of the reaction profile. So start temperature for the first one is 21, and the end temperature is going to be 51. Okay, so if we draw a rough sketch with 0 here, 20, 40, 60. Okay, so the start temperature is going to be 21, and the end temperature is going to be about 51. So that's going to be end temperature there. So our reaction profile is going to look something like that. So it starts at 21, the reactants, and the end is 51. Okay, now that is a reaction for an endothermic. That's an endothermic reaction profile, because an energy of the products is higher than the energy of the reactants, therefore it's endothermic. So for number 2, let's have again another rough guide, 20, 40. So it starts at 22, starting somewhere around here, and it finishes at 28. It's going to end around there, so it's going to be something that looks like that. Okay, so it's something that looks along those lines, and again, the energy of the products is more than the energy of the reactants, so that's going to be an endothermic reaction as well. Number 3, we're going to draw that here. Again, another rough guide. It's 21 and 9, so 0, 10, 20, 30. It starts at 21, so it's going to start somewhere around here, and it's going to end at 9, so it's going to end somewhere around there. Okay, so that it's going to look something like that. Okay, now that is a reaction profile for an exothermic reaction, because the energy of the products is lower than the energy of the reactants. And finally, question 4, our final reaction profile, 0, 10, 20, 30. It starts at 20 and it ends at 25. So we draw that, complete the dots. So it's going to look something along those lines, and it is again going to be an endothermic reaction, because the amount of energy of the products is more than the energy of the reactants. So I hope you were able to draw those and be able to identify which was exothermic and which was endothermic. You can now move on to answering the quiz and the exam questions on this topic. If you didn't understand anything, then please get into contact with one of our tutors who will happily help.